Hello, I'm Mr. Birnbaum, and today we're going to be using a BCA table to find limiting reactants. And in this question, we've got 26.4 grams of nitrogen, 5.25 grams of hydrogen. So here's our balanced equation, and we want to know how many grams of ammonia, NH3, we're going to have at the end of this. So here's our BCA table. B stands for before, C is the change, and A is after. So this is just for putting in the number of moles. Now we've got grams here, so we're going to have to convert those grams into moles to put into here. So let's do that. So for our nitrogen, our N2, we've got 26.4 grams. And so to convert that to moles, we're going to have to use a periodic table. So nitrogen is 14, but since we have an N2, we're going to divide this by 28.02 grams. Okay. And that's going to equal 0.942. We'll do the same thing with the hydrogen. So we've got 5.25 grams, so we got to convert that to moles. So for hydrogen, we have 2 of them. So when we look on the periodic table, we have to double that number. So it's going to be 2.02 grams. And you can use your calculator for this. This is going to be 2.6. And both of these are moles. So both of those are moles, so that we can put them in the BCA table. So now I'm going to put the 0.92, and this is nitrogen, so I'm going to put it in the N2 column for the before. And then for the H2, let's see, this should be H2, I'm sorry, that should be H2, not water. So H2 is going to be 2.6 moles. So here in the H2 column, I'll put that in. 2.6. And then for the ammonia, in the before we don't have any ammonia yet, so we're just going to put a 0 there. Okay. So this is for our nitrogen, number of moles. Our hydrogen, number of moles. All right, so let's continue on here. So when we end up, we're not sure what the change is, but we do know that we're going to lose proportionately 1 nitrogen. And since the number is unknown, I'm going to use an x. And it will be a minus 3x here. And then for our NH3, we're going to gain 2 moles. Okay, so whatever our x is, this is the proportion, our 1, our negative 3, and our gain of 2. So we can figure this out algebraically. We can take what we started with, 0.942 minus x, and then for up here, we can do the same. 2.6 minus 3x. And then this one will just be 2x. So we can start off by solving for x here. And so if we have 2.6 minus 3x, and if we use it all up, it's going to equal 0. So we can add 3x to both sides. And then that's going to give us 2.6 equals 3x. And then we'll just divide both sides by 3. And that's going to give us 0.866 equals x. So this is our value for x. And what we can do is we can take this x and we can substitute it into here, and we could substitute it into here. Okay? So let's go ahead and do that. So if I take 0.866 and I double it, I'm going to end up with let's see, 0.866 times 2, and that's going to equal 1.73 moles. So I'll have 1.73 moles of NH3. And I've got 0.866 moles of H2. And then if I multiply the 0.942 to 0.866, that's going to give me 0.07 moles right there. Okay. So now that I've got these ratios, I'm going to put these in here. Let me change that. So 0.07, 0.866, and 1.73. Okay, so these are all moles. Okay, so now we need to figure out how many grams of ammonia is produced. So if I've got 1.73 moles of NH3, and let's see here, NH3 is going to weigh 17.04 grams per mole. And if we calculate this out, we're going to get 29.5 grams of NH3. So this will be our final answer to our question. Now if we wanted to figure out which one of these we're going to run out of first, we can take a look at these. If we look at these ratios, we need to have 3 times more H2 and 3 times more of H2 than N2. So let's take our number of moles of N2, 0.07, and then let's just times it by 3. We have 0.21. So we would need 0.21 moles of H2. Hi, this is Mr. Birnbaum. She's absent today. Yep, bye-bye. So it would take 0.21 for the H2. And so if we look at our H2, we don't have 0.21, we have less than it. So we're going to be running out of this one. So this is going to be our limiting reagent. So now you know how to use the BCA table to use your mole conversions, as well as the periodic table to convert from moles to grams and grams to moles, and also to calculate using proportions to find out which of the reactants you're going to run out of first. Those are called the limiting reagent. The one that's not the one you run out of first is going to be referred to as excess. Okay. So thank you for watching this video. Please do not subscribe to my channel or give it a thumbs up. See you in class.